Continuing. Continuing on to 2.6. Honda Civic is traveling along a road. The car's distance is given by this function here. Now we have some Greek letters that have values attached to them, and so they're choosing to give you this kind of as in a parametric form where you have a value for alpha assigned and a value for beta assigned. Keep in mind these do have units. So I'm going to start by rewriting my function with these values substituted. So x of t will be equal to alpha, which is 1.50 meters per second squared, times the square of time, minus beta, which is 0.0500 meters per second cubed, multiplied by the cube of time. So part A, well actually all of these, says to calculate the average velocity of the car for each time interval. So the time interval for A is from t equals 0 to t equals 2 seconds. So I want to calculate average velocity. I'm not asking for instantaneous velocity. Average velocity is simply change in position over my time interval. So my change in position, remember, is going to be in this case x of t2 minus x of t1 all over t2 minus t1. So in this case, I'm simply going to be substituting values for my time into my position function and finding the difference in those two values. So I'll completely write this out for part A. So x of t2 is going to be 1.5 meters per second squared times the square of t2. So my t2 is my second time, in this case 2 seconds, which I will square. Subtract from that 0.5 meters per second cubed, and multiply that by the cube of t2. So this is still t2, so that's 2 seconds cubed. So that is my x of t2. From that I'm going to subtract x of t1. Well, this case t1 is 0, so anything times 0 is 0. Since both of these have t terms, that is quite simply 0. In the denominator, I simply have 2 seconds minus 0, so we can simplify that quite easily. And you see that this works out to be, we go to our calculators, be careful of the sign, do not forget to subtract, and do not forget to cube your times. You end up with an average velocity of positive 1 meter per second. And I see it's positive because of simple algebra, and I see that my units are meters per second because I end up with, this should be meters per second cubed, should it not? I believe there is a slight mistake in this one. I believe this should be, oh, no, that's right. So I have meters on top over seconds. Second guessing. So this is my average velocity for the first time interval. If I go through the same process for part B, t1 is 0, t2 is 4 seconds. I will see that my average velocity, if I set it up, will be, and I will skip writing my units this time as we've already addressed them, will be 4 seconds squared minus 0.5 times the cube of 4. From that I'm going to subtract, again, 0, this time over 4 minus 0. And so my average velocity for this part will end up being, I'll go ahead and write this further to the right, will end up being, if I square my 4, multiply by 1.5, from that subtract 0.5 times 4 cubed, I end up with negative 8 divided by 4 gives me an average velocity of negative 2 meters per second. So the only difference now for part C will be I'll be plugging in 4 for T2 and 2 for T1. So I have 2 seconds is t1, t2 in this case, 4 seconds. So my average, I'm going to need more space here, is going to be 1.5 times the square of 4 seconds, because remember this is t2, minus 0.5 times the cube of 4, cubed, there we go, over, I'm sorry, I need to keep going here. My subtraction in this case is not 0 because my time 1 is not 0. So I actually need 1.5 times 2 squared minus 0.5 times 2 cubed. And don't forget, all of this is being subtracted, so I need to make sure I distribute that negative sign later, over 4 minus 2. So I've set this up. Now it's time to just go to the calculator and do your due diligence. The intermediate steps will look something like this. So I will have 4 squared times 1.5, which should give me 24. The second term, 4 cubed times 0.5, should give me 32. From that, I'm going to subtract, and I'm going to go ahead and leave my parentheses in here, 1.5 times the square of 2, which works out to be 6, minus 0.5 times the cube of 3, which works out to be 4, all over 2. So my average velocity for part C is going to be 24 minus 32, minus 6 times 4, which is 2, all over 2. And so this gives me an average velocity of negative 5 meters per second. So you can see that this is quite an involved problem. In order to find average velocities, you simply just need to plug in different time values into our position function and find the difference in order to find displacement. So this definition for average velocity should always be somewhere in the back of your mind.